Hi guys, I'm live. How you guys doing? I want to do a video on the numbers of frequencies of notes, maybe on the guitar and intervals and all that, using the overtone series and ratios of frequencies. It's kind of a math music thing, so maybe let's just jump right in. So middle C is the 5th fret of the G string on the guitar, or the 1st fret of the 2nd string, which is the B string, or the 10th fret of the D string, the 4th string, or the 15th fret of the A string, the 5th string, or the 20th fret of the low 6th string, E string. And Western music is tuned to A440. A is 440 hertz, and A is the A that's above middle C. So if middle C is the 5th fret of the 3rd string, then A440 would be a major would be a major 6th above that, which would be the A on the 5th fret of the high E string, which would then make that note 440 hertz. That's the 5th fret of the high E string. So then by the rule of when you go down an octave, you divide the ratio by 2. When you go up an octave, you multiply the ratio by 2. The frequency by 2. So if you to go down an octave from A440 would be would be 440 divided by 2, which is 220, and down an octave from the 5th fret of the high E string would be the 2nd fret of the 3rd string. That would be the frequency A, and it equals 220 hertz. And then the open A string is an octave below that, so you divide that by 2. So the open A string is A110 hertz. And then just for fun, you can find the frequency of the low E string, because if the open A string, 5th string, open 5th string is 110 hertz, then E, the low E string, is a perfect fourth below that. So the ratio for a perfect fourth on the overtone series is 4/3. If that's to go up a fourth, you would multiply by 4/3, or you could say multiply by 4 and divide it by 3. But to go down a fourth, which would be from the open 5th string to open 6th string, you would multiply by the reciprocal of 4/3, which is 3/4, which is 0.75, or 3/4 is 0.75. So if you take 110, which is the open A string, and multiply by 0.75, or you could say multiply by 3 and divide by 4, you get about 82.5 hertz, and that's about the frequency of the open low E string. So the math works in all this. And another thing I think is interesting is that you can find, if all you knew was middle C, and you wanted to find what the A above middle C was, you could start with this. You could say middle C is 5th fret of the 3rd string, which is frequency is 261 hertz, and then to get the A above the middle C, you have to go up by a major 6th, because from C down to A, the nearest A below it is down a minor 1/3. So that means that C up, the A above middle C, a C, would be up a major 1/3 from C. Up a major 6th from C, because the inversion of a minor 1/3 is a major 6th. So one way to find what the frequency of the A above middle C would be, just by using math, would be start with C equals 261 hertz, and then you have to go. One way of doing it is you have to go up a major 6th from there, and A is a major 6th above C. And one way of doing this, one really cool way is that, what is a major 6? So a major 6 is a perfect fourth plus a major 3rd. And what are those ratios on the overtone series? Well, a perfect fourth is 4/3, ratio. A major third is 5/4 ratio. So if you want to add the two intervals, fourth plus major third, you would multiply the ratios 4/3 times 5/4. The fourths cancel out and you get 5/3. So a major 6 is 5/3 frequency. So if you start with 261 hertz, which is middle C, and multiply by 5, divide by 3, or multiply by point, or you could say multiply by 1 2/3, which is 1.6666, etc. You get something like 435 hertz or something, which is very close to 440. So you know you did it right because you're close. The number, you don't have to get the exact number. A lot of this is approximation because we're using equal temperament, which is based on the half step being the 12th root of 2, which is a really irrational number, and it's very inexact as compared to the perfect ratio frequencies of the overtone series, which are they can only approximate each other. They don't come out to the exact same things. But another way of doing this, if you knew middle C was 261 hertz, you could say, now what if I want to know the A above middle C? Well, you could say this. You could say, well, I want to go up a major third. Up a major 6. I keep saying major third. Up a major 6 is up to A. So that's also down a minor third. But up an octave. So how do you go down a minor third? Well, ratio of a minor third is 6/5. But that's going up a minor third. So down a minor third would be 5/6, which is the reciprocal of it. But if you go 5/6 is down a minor third, you want to go up an octave from that, you have to multiply 5/6 by 2/1 because going up an octave multiplies it by 2. So 5/6 times 2/1 is 10/6. But 10/6 is equal to 5/3, and that's the same result we got from using overtone series to find out that a major 6 is 5/3 because a major 6 is a perfect fourth plus major third, and perfect fourth is 4/3. Major third is 5/4, and then therefore a perfect fourth plus major third is 5/3. So I just think it's interesting. I haven't done a video exactly like this before. It's technically not frequency orientated. I don't usually think of frequencies on the guitar. But it's interesting to know those things, It's interesting that if someone says play A440, it's interesting if you can play the 5th fret of the high E string and know that that's A440, rather than just, I don't know what A is, it's just an A. Well, the more knowledge, the more you have to go on. So knowing these little tricks and knowing this math is actually kind of cool, I think. What would be you could ask this question, what would be the frequency of the 17th fret of the high E string? Well, that would be an octave above 440 because A440 is the 5th fret of the high E string. So an octave above the 5th fret is the 17th fret. And if the 5th fret is A440, to go up an octave, you multiply by 2. Going up an octave multiplies it by 2. So that means that the A on the 17th fret of the high E string would be the frequency ratio, would be at frequency 880, because 440 times 2 is 880. Anyway, love you guys. Peace, love, rock and roll.